this, we have the definition of an absolute value, which is, we actually wrote this one, I think, last week, a number's distance from 0 on a number line. Number's distance from 0 on a number line. So remember, the absolute value of a negative 5 would be a positive 5. The absolute value of a negative x would become a positive x. And then we're actually going to skip the algebraic definition because it will confuse most of you more than it will help you. So we don't need to know it. But in years past, I've had students get like confused by all the letters and stuff, so we're just going to skip that. You don't need to know it to do the problems. Now, when we're doing this and solving our equations today, we are going to have to check for extraneous solutions. What do you think an extraneous solution is? Think about the root word that's in there. Extraneous. Extra, right? So an extra answer, it's an extra answer that's not actually an answer. So you have to check both of them and make sure that they really work. Because sometimes when you modify both sides of an equation, you can actually get an extra answer that doesn't actually satisfy the equation. So I know it'll be tedious, but we will check these. So by definition, it is a solution of an equation derived from an original equation that is not a solution to the original. But for short, it's an extra answer that doesn't actually work. But because these pop up, we will have to check both of our answers in the original by plugging them back in. And we'll have to make sure that they work and get us that same number. So it's a little bit time consuming without a calculator especially, but a lot of it's mental math you could do in your head. All right, so we have some steps to solve an absolute value equation. Step 1 is the most important one, and it's the one that a lot of you will forget when you solve the longer. And that is to isolate the absolute value on one side of the equal sign. So isolate means to get alone, get by itself. So I'll give you an example here. I'm going to make my absolute value bars a little bit. So 2 times the absolute value of x minus 1, those are your absolute value bars, plus 1 equals 11. First and foremost, you cannot distribute. So put this in your notes. Cannot distribute. Absolute values work like parentheses in that they group things inside. They do not work with the distributive property. So you cannot take an outside number and put it inside the absolute values. All right. When I say isolate the absolute value, that means I want to get this thing alone. So I want to move everything else over. What would I do first?
Subtract 1 from x and get negative.
No.
Subtract 1 from 11.
Subtract 1 on both sides. You want to get rid of this one. This stuff has to stay together for right now. So we'd have 2 times the absolute value of x minus 1 equals 10. Again, we can't distribute this. I want to get the 2 on the other side. John? Divide. And so we'll get the absolute value of x minus 1 equals 5. Okay? And then I'm going to show you in the steps how to do the rest of it. But this is the most important step. Now, sometimes it will already be isolated and you won't have to do that. But that is always your first step. Once you get it isolated, then you're going to set up 2 equations. One, where what's in the absolute value will be equal to the positive 5, and one where we set it equal to a negative 5. So you take what is inside the absolute value, the x minus 1, and you'll set up a positive and a negative. So we'll say x minus 1 could equal a positive 5. Or x minus 1 could equal a negative 5. Now some of you are like, Mrs. Bennett, this makes no sense because I know the absolute value is always positive. But remember, we're thinking about what's inside of here. So if x minus 1 gets me a negative 5, when I take the absolute value, it would become a positive 5. That's why we have to inspect both possible cases. So you solve each equation, and that's probably what this says. Solve both equations. So we'll add 1 to both sides. We'll get x equals 6. And we'll add 1 to both sides here. Negative 5 plus 1 is negative 4. Now, the last step is that you have to check for extraneous solutions, which means you have to take and plug those numbers back in and make sure that they satisfy the original equation. Whoops. You cannot check it in this one that you've modified. You have to check it in the very top equation. So we'll just do it in our head. 6 minus 1 is 5. The absolute value of 5 is 5. 2 times 5 is 10. 10 plus 1 is 11. So this one works. Give it a check. Take your next one. Negative 4. Negative 4 minus 1 is negative 5. The absolute value of negative 5 is positive 5. 2 times 5 is 10, plus 1 is 11. This one works too. So you can have two answers. I would say about 80% of the time you're going to have two answers. But there is that 20% where you may have an extra one, and you literally will cross it off. It's not a solution. All right, let's start off with some easy ones. Notice again, step 1 is always to isolate your absolute values, which these ones, lucky for us, are isolated. All right, so we can move right on to step 2. Step 2 tells us to take what is inside the absolute value, the expression that's in there, and set it equal to a positive 12 and a negative 12. So we have 2y minus 4. You don't change anything about the expression, like you don't make it 2y plus 4. You don't change the symbols. Keep it exactly as is. Set it equal to a positive 12 and set it equal to a negative 12. And solve each equation, which we should all know how to do by now. We'll add 4 to both sides. Divide by 2. Actually, maybe we don't want to circle it until we've checked it. That would be a good process. Don't circle it until you have checked it. Do the same thing with the other one. Add 4 to both sides. Just be careful with your negatives. Remember, negative 12 plus 4 means you're actually subtracting them to get 8, and you keep the sign of the larger, which will get me negative 8. Negative 4. Now, I'll show the check, like, to show you in case you want to have work. So we would have 2 times, we're taking this answer and plugging it back in for y. In the original, not this one, the original. 2 times 8 minus 4 equals 12. So we'll get 16 minus 4, which is 12. 12 equals 12. So that one works. Let's circle it. And again, you can do it in your head if you want to. But on a test, if you don't check them and one of them is extraneous and you keep it, you're going to lose points. So just be aware of that. Check the other one, plugging negative 4 in. So we'll have 2 times negative 4 minus 4 equals 12. That gets me negative 8 minus 4, which is negative 12. The absolute value of negative 12 is 12. So this one also checks. So we have 2 answers to this problem, either 8 or negative 4. Why don't you guys try this one on your own? I'll set it up for you, and we're going to take what's inside the absolute value and set it equal to a positive and a negative 6. Go ahead and we should be saying yes. We do both check. Does anyone need me to show the work for that? Should we not get 3 or 7? Okay. On the back, we're going to make them harder. Actually, we're going to go back and make them as hard as they were when I showed the first example problem. Okay? All that that means is you have work to do before setting up your two equations. What you cannot do right now is set up two separate equations. Remember that step 1 is to isolate the absolute value. Okay, so what am I going to do to isolate my absolute value? And I want to isolate these. I want to get them by themselves first. Done? Add 5 first. Very good. Can I distribute the 3? No, there's no distributive property that exists for absolute values. So instead of distributing, I will do the inverse of multiplying, which is dividing. I can't tell you how many of you will distribute the 3. Hopefully me yelling just now will remind you not, but we'll find out on Wednesday, your chapter 1 test. All right, now that we've isolated our absolute value, now we take what's inside the absolute value and we can set it equal to a positive 5 and a negative 5. And this is one topic that some of you may have learned in Algebra 1 and some of you may not have. It kind of depends on if you took it at the middle school or the high school. Sometimes they don't teach this. And we just solve this. So we'll add 1 to both sides. 4w equals 6, divide by 4. Again, those of you struggling with fractions, like you don't need a calculator to take 6 divided by 4. Your answer is 6/4. We could reduce it though, right, to be 3/2. You also could make that 1.5 if you prefer. Okay, on the other side, we'll add 1 to both sides. 4w equals negative 4. W equals negative 1. Now, remember, you have to check these, especially since we manipulated them in a great way. You have to check them in the original, which is going to make it a little bit harder. Now, if you don't want to have to do 1.5 times 4 on the side and do your math, you might want to leave it as a fraction. 4 times 3/2 minus 1. Okay, remember, for fractions, you just put this over a 1. Multiply the tops, multiply the bottoms. So we're going to get 12 and 2. 12 divided by 2 is 6. Okay, 6 minus 1 is 5. The absolute value of 5 is 5. 3 times 5 is 15, and 15 minus 5 gets me 10, which is what I wanted. So this one works. Okay, the negative 1, let's just do it out loud / in our heads. So plugging in negative 1, we'll get 4 times negative 1, negative 4. Negative 4 minus 1 is negative 5. The absolute value of negative 5 is 5. 3 times 5 is 15. 15 minus 5 is 10. So now some of you are convinced that I'm making you check them for no reason, right? Why the heck do we have to check them? They've all worked. This is a waste of my time. The next example will have an extraneous. Aiden.
Could you plug it into the yeah.
No.
Oh. Okay.
No. And you'll see why in the next example, but you have to plug it into the original to make sure it's a solution of the original, because we've modified the original by moving stuff around. And sometimes when you do that and move stuff around, you can impact what the answer would be. Okay, so let's see one where we'll get an extraneous. What's different about this one than the last one?
Variables on both sides.
There are variables on both sides. Okay, so something to consider is that when there are variables on both sides, there is a higher likelihood of an extraneous solution. All right, step 1, as you remember, is to isolate your absolute value bars. Well, to me, they look like they're alone. Now, some of you will try to move the 3x over right now. You cannot do that, okay? Because one of them is in an absolute value, one of them is not. Okay, so you cannot move anything around. You go straight to step 2, which is to set up two equations. We're going to set up a positive and a negative. Now, normally we've only had a number there, so we had a positive 15 and a negative 15. This time we're going to have 2x plus 5 equals just exactly what you have, 3x plus 4. Keep it the same. Now the negative, you actually need to negate both of them. So it'll be 2x plus 5. Remember, this part stays as is. You don't touch it. This will equal, and I'll write negative parenthesis 3x plus 4. If you prefer, you could just go straight to negative 3x minus 4, but you're taking the opposite of the whole expression. Okay, so that will get us 2x plus 5 equals negative 3x minus 4. Now you can solve these and move your x's to the other side and do all of your algebra. Okay, so maybe subtract 2x. There's multiple ways to do this, of course. Subtract your 4. So x equals 1. Oh, I said I'm not supposed to circle them until I've checked them. Keep doing it. Add it. Now the other one, instead of subtracting 2x, I'd probably add 3x. Again, you'll notice that my personal choice is I always move the smaller one. So negative 3 is smaller than 2, so I'll move it. And then just be careful, this was a negative 4. Bless you. Okay, again, fractional answers. There are answers, it's right in front of you. It's negative 9/5. Don't need a calculator to type that in. All right, so now we need to check them. And this is the one, Eden, where you really need to check it in the original one, where the absolute value was, not these ones, because it'll always work in those ones, because we've modified them. So always check it in your original. So we'll have, I'll show my work over here, 2 times 1 plus 5 equals 3 times 1 plus 4. 2 times 1 is 2, plus 5 is 7. The absolute value of 7 is 7. On this side, I'll just have 3 plus 4. So I do get 7 is equal to 7. So this one is an answer. I already told you 1 doesn't work, which means it's the next one. But let's make sure we know how to do it with a fraction, right? And we'll have to plug this in without a calculator. So we'll have the absolute value of 2 times negative 9/5 plus 5. Does that equal 3 times negative 9/5 plus 4? Okay, we need to multiply first. So 2 times negative 9 is negative 18. 1 times 5 is 5. And at that point, you might want to find a common denominator. 5 over 1, we need a 5, so this has to be 25/5. All right, 25/5 is still 5. What do I get when I take negative 18 plus 25? Here? Yeah, 7/5. And then the absolute value of 7/5 is just 7/5. We do the same thing on the other side, but there's no absolute value over here. So we'll have negative 27/5 plus 4 over 1. All I do is multiply these, okay? 4 over 1, I'm going to go ahead and make this have a common denominator of 5, so I'll have 20/5. And negative 27 plus 20 is negative 7/5. These are not equal. One is a positive, one is a negative, and this side didn't have an absolute value so that you make it positive, which means this is an extraneous answer. Cross it off. Do not leave it on your paper visible. Please put an X through it. The only answer to this problem is the number 1. All right, I'd like you guys to try example 3. Oh, let's do the closure real quick, and then we'll have you do 3. Because those are just more practice. They're exactly like the ones above. It says the equation, the absolute value of 2x plus 7 equals negative 2 has no solution. Without solving, explain why this is true. Mira?
Because no sum of absolute solution equal negative.
Say that again?
Nothing inside of the absolute solution equal negative.
Right. When you take the absolute value of, say, like, let's say this was negative 2. When you take the absolute value of negative 2, it can't get you a negative, it would have to be a positive. Okay, the absolute value will always yield a positive number. Now, when we solve them, we take away the absolute values and we set them equal to a positive and a negative. But because the original equation had it set equal to a negative, it's not possible. No matter what number you plug in for x, even if you get a negative number inside, you're going to take the absolute value, which would make it a positive. Just a quick note, your homework is on Google Classroom. No worksheet today because there's not that many questions. So when you're on Google Classroom, just make sure that you do open up the 1.5 day 1, not the day 2. And, whoops. And I did put, as I said, at the top, so you can see this is tonight's homework this weekend. That'll be Monday nights, and then this will be Tuesday nights. If you want to start working on it, it's the chapter review to help you study. So make sure that you show all of your work for these problems. I'd like you to copy the problem and show your work. Looks like I didn't put answers to these. Ooh, no answers. So we'll see if you get them right. If there's no answers posted, anyone have an idea what I might do on Monday?
Not post them.
Nope. Do an accuracy check.